Okay, so good evening, guys. Tonight we're going to talk about alternating current network analysis. So this network analysis is all about the superposition theorem. Okay, so these are the objectives of the discussion for tonight. So at the end of this topic, you should be able to appreciate available methods of analyzing networks. You can solve now simultaneous equations in 2 or 3 unknowns using determinants and analyze AC networks using superposition theorem and solve AC networks using superposition theorem. So this is another theorem that we're going to discuss with AC analysis. So last week we have talked about Kirchhoff's and pa ba? We have mesh and we have the nodal analysis. Okay. So again, this superposition theorem is the same or similar with the superposition theorem that we have discussed or you have learned in your DC analysis. Okay, so the concept is still the same. Okay, so the concept is still the same. All the steps are still the same. Kaya lang, again, uh, the difference now would be the values of the sources. Okay. So again, the superposition theorem states that in any network made up of linear impedances and containing more than one source of EMF or electromotive force, the resultant current flowing in any branch is the phasor sum of the currents that would flow in that branch. So if each source were considered separately, all other sources being replaced at that time by their respective internal impedances. Okay. So what do you mean by that? So let's have these examples. Okay. So the superposition theorem, which was introduced in DC circuits, may be applied to both DC and AC networks. Okay. So we have a network here that will serve to demonstrate the principle of application of the superposition theorem. Okay, so we have an E1 here, or this is a voltage source which has 8 volts, and another voltage source here which is equal to negative 3. Actually, this is 3 lang. Okay. This is now for this portion of the circuit. So the current flow is assumed, okay, is assumed to be in a clockwise direction, while on this part of the circuit, okay, so uh, the direction flow, the direction, okay, so the direction of the current flow is anti-clockwise. Okay, so we have here some other components. We have an internal resistance, R1 or small r1, which is equal to 1 ohm, and we have uh, another a component here, which is another internal resistance of this loop, okay, of this loop, which is equal to 2 ohms, and we have a load resistance here which is equal to 5 ohms. Okay. Now, to find the current flowing in each branch of the circuit, so these are the following steps or procedures that we have to adopt. Okay. So first, we're going to redraw the original network with one of the sources, di ba? With one of the sources. Okay. Let's say we have E sub 2 to be removed and replaced by R2 only as shown. So this is now our original circuit. Okay, so kompleto pa yung ating components. We have here E1, we have here E2, and then we have the internal resistances and the load resistance. Now, we're going to remove one of the sources. So for this example, for this discussion, we're going to remove this E sub 2. So if we have removed that E sub 2, that will only be just a straight line or a single conductor. So this will now be the equivalent circuit. Okay? So with this, okay, so if our current flow for E sub 1 would be counterclockwise, then if we would assume or consider this as a node, so I1 would be entering the node, okay, and then I2 will be leaving the node, and also I3 will be leaving the node. Okay, so this will also follow the clockwise direction of the current flow. Now, this will now be the bigger part or bigger version of the circuit. So we have removed the E sub 2 here, or the other voltage source. So we have already assumed all the current flow, or the direction of the current flow. So we have here the I1, we have here the I2, and then we have here the I3. Okay, so what you could notice here would be, so in taking out E sub 2, you will notice here that our load resistance R and our resistance R2 are now connected in parallel. Okay, so if they are connected in parallel, so we could have an equivalent resistance for the big R and R sub 2. So let's just apply the formula uh for the formula in knowing the equivalent circuit of or equivalent resistance of a parallel circuit. So we could make use of the product over sum method, wherein we could say that the big R, okay, multiplied by the small r sub 2 divided by r plus r sub 2. Okay, so this will now be equal to, so we have here the equivalent. We have 5 multiplied by 2, so this is 10 over 5 plus 2, this is 7. So we have 10 over 7, and the equivalent resistance now would be equal to 1.429 ohms. Okay, so this could now be redrawn. Okay, okay. This could now be redrawn as, so if this is our E1, okay, so we'll now have, okay, an equivalent circuit like this one. So this is E1, okay. So our uh, direction flow. So this is now the R equivalent, okay, which is equal to 1.429 ohms, and still we have R sub 1 here, which is equal to 1 ohm. Okay, so let's go back. Okay, so this will now be the equivalent circuit. So we have here our R1. Oops. Okay. Our R sub 1, which is equal to 1 ohm, and we have 1.429 as our R equivalent, no? Okay, so you would see here that the two are, so we could now determine here I1. So so by using current divider formula, we could now determine I1. Okay, so our current divider would be equal to this. Okay, Okay, so that will be E1. Sorry. Actually, sorry. The two are connected in series. Sorry about that. So the two are connected in series. So therefore, we could determine I1 by having uh, the sum of R1 here and R equivalent. So that would now be equal to the voltage. So by Ohm's law, di ba? Current is equal to the voltage divided by the resistance or the impedance. Okay? So that will now be equal to the 8, okay? 8 volts coming from this, and we have a combination or the total resistance in series, which is equal to R1 plus R equivalent, which is 1.429, and that is 2.429. And then current I1 now would be equal to 3.294 amperes. Okay, so to continue, to continue, when we try to redraw again the circuit uh, using the one that we have taken out, E2, we could now determine I2 and I3 by means of current divider. So we could see that the big R is in parallel with R2, and then we have already determined I1. Okay, so we have an I which is entering this node that will now be divided into I2 and I3. So if the current will now be divided, therefore we could make use of the current divider formula. Okay? So the current divider formula is equal to, for I2, we could now determine, we could have R sub 2 over the sum of R and R2 multiplied by the given current, or the current that we have already determined. Okay, so that is I1. So R2 would, substituting, so R2 would now be equal to 2 over 5 plus 2. Okay, and then multiplied by 3.294. Okay, so that was the current that we have taken from I1, or we have determined from I1. So therefore our I2 now would be equal to 0.941 amperes. Okay, now for I3, we could make use again of the voltage divider formula, current divider formula. So I3 will now be equal to, again, the source. Okay. So we have the source current of 3.294. Let me just okay. So Engineer Leo will not be joining us, will not be joining us, so meron silang mga emergency meeting. Anyway, let's go back. Okay, so for the current I3, we could now determine I3 by, again, current divider formula. So we have, 5, okay, divided by, So 5 divided by the sum of R of the big R and the small r. Okay? So that, and then multiplied by I1, and therefore our I3 now would be equal to 2.353 amperes. Okay? So those are the currents that we have determined. That is using E sub 1. Okay? So how about using the E sub 2? We're going to short this one, and then we're going to make use of E sub 2 instead. Okay? So it will now be like this one. So redrawing this, so we now have E sub 2, okay? E sub 2 of 3 volts, and then we have the internal resistance of 2 ohms. And then we still have the load resistance or load impedance, and then the internal resistance of E1. Okay, so as our assumption tells us that the direction of the current is anticlockwise. So therefore, this we can make note. We can note this as our I4. This is our node, and then the current, the I4 will now be divided to the component R and the component R sub 1. Okay, so if that will now be divided, so this can now be assumed as our I5, and this can now be assumed as our I6. Okay, so we do this we do similar process like we did before. Okay, so we could see that R sub 1 and R are connected in parallel, so we could have an equivalent resistance of this. So we could make use again of the product over sum method, and that is equal to 5 times 1 over 5 plus 1. Okay, and that is 5 over 6. Okay, so 5 over 6 is equal to 0.833 ohms. So that will now be the equivalent resistance. Okay, so to determine I4, okay, dito muna tayo, no? To determine I4, so this is our R equivalent to, okay, which is 0.833, and we have the internal resistance of 2 ohms. So the internal resistance of E sub 2. So we could see again that the two are connected in series. So therefore we could just take the sum of the two, okay, and then we have it as our divisor for our we can have it as our divisor for our voltage source, and it will give us the corresponding current, okay, or current I4. Okay, so that is 3 over the sum of 2 and 2 and 0.833, and that gives us 2.833, and 3 over 2.833 is 1.059 amperes. Okay, so we have already determined this, and this current now will be divided, okay, will be divided into I5 and I6. So how could we determine that? So we could now determine that again by using current divider formula. Okay, so to determine I5, we could have, okay, we could have R1, okay. So to determine I5, that is R1 divided by sorry. Okay. Okay. So we could now have R1 plus R, okay, multiplied by I4, which is multiplied by I4. Okay. So that is, so we have 1 over 1 plus 5, okay, and and that is multiplied by 1.059, and it will give us, okay, it will give us uh, 0.177 amperes. Okay, and then we could now also determine I6, okay, again by using current divider formula. So that will now be, so I6 now would be equal to R over R plus R sub 1, okay, multiplied by I4. Okay. So that is 5 over 5 plus 1, okay, multiplied by I4 of 1.059. Okay, and it will give us 0.8825 amperes. Okay, now, so those are the currents that we have determined using E sub 2. But remember, the original circuit is we have E sub 1 here, or we have another voltage source here. So what are we going to do with this? Okay. So by the name that it implies, superposition theorem, okay, superposition theorem, so we're going to superimpose the previous network. So what do you mean by superimpose? So ipag-join natin, we're going to join the all the uh, values that we have determined using the E sub 1, and we will have to join this with the circuit with E sub 2. Okay? So, kung mapapansin nyo, so we have two identical circuits. Okay? So, ito yung circuit na ang ginamit lang natin ay okay, yung 8 volts or yung E sub 1. And at the back, okay, ito yung circuit na ang ginamit naman natin ay yung E sub 2. So, ito yung kanyang circuit. Yan. Okay? So, we're going to superimpose this, or we're going to join them. Okay? So, when we superimpose this, we will see that, okay, we will notice that I sub 1 and I sub 6 are in opposite direction. So, therefore, the current flowing here would be I1 minus I6. Okay? So, similarly, in this circuit, you will see that I3 and I4 are do have a different current flow. Okay, so they are opposite. So we could now say that that is I3 minus I4. Okay, and then look at I2 and I5. Okay, so I2 and I5 have the same current direction. They are uh, the direction is going down, so that would be, so if they have the same direction, then we could just simply add them up. So the resultant current flowing through the 5 ohm resistor, 5 ohm resistance would be I2 plus I5. Okay? So with that, so malalaman natin ngayon na yung ating current, okay, yung ating current na nagpo-flow dito sa ating, let's have the original circuit here. Wait, here. Okay. Then we have, so this is R1. and this is R2, and this is our big R. Okay, so the current flowing here, okay, so the current flowing here would be equal to I1 minus I6, which is equal to 2.41 amperes. Okay, and yung ating current flowing here, okay, would be equal to I3 minus I4, and that will now be equal to 1.29 amperes. And the current flowing through R5 now would be, okay, would be I2, okay, would be I2 plus I5, and that is equal to 1.12 amperes. Okay, so that will now be the current flowing through the resistance R. Okay, so you could make use of this formula even though we have more than two voltage sources. Okay, so any question? Any question?
Wala naman, sir.
Wala naman. Okay. So if you have no more questions, then let's call it a night. So we're going to have it. So please, please monitor your canvas. Okay? Dahil maglalagay ako doon ng mga assignments naman. Okay? And then for Wednesday and Thursday, please make use, please do lab activity 9. And then we'll have another lecture by next week. Okay? Sabi ni Sir Leo, next week na lang daw siya magjo-join sa atin. Okay? So next Monday. Ano ba yung next Monday? 2. Okay? On May 2. Okay. So that's it, guys. So let me just get your attendance.
Sir,
Attendance.
yung diniscuss niyo po, sir, yung PowerPoint, sir, nasa module na po.
Oo, nasa canvas na natin.
Okay po, sir.
Then later on, I'll also upload the video. Okay?
Okay po, sir. Thank you po.
Yes. Yeah, let me just get your attendance. Elizabeth? Elizabeth, wala. Grizel?
Present, sir.
Carlos?
Present po.
Patrick?
Present po, sir.
Adrian?
Present, sir.
Present po.
Adrian?
Present po. Present.
Clint? Clint? Wala. Ramil?
Present po.
John Maury?
Present po, sir.
Eduardo?
Sir, present po.
Rob? Rob Limbo? Wala. Bernard?
Present, sir. Present.
Brennan? Brennan, wala. Michael, Natividad?
Present, sir.
John Micah?
Present po.
Leonard? May balita ba kayo dito kay Leonard? Di naman ito nagpapasok. Rina?
Present, sir.
Stephanie? Stephanie? Mike? Oliver? Oliver? Okay. And Russell?
Present, sir.
Okay.
Sir, present daw po si Roy Bibar.
Oo, nakita ko. Okay, thank you. So,